Okay, here we go. Everybody's got the food you need. If you want more, just go help yourself, get some more. Try not to disrupt because we got some learning to do here. So the first thing we're going to do is a quick review of what we have already talked about in this chapter, briefly, chapter 8. And that is, you're pretty much on your own with the circles, but I did do a couple of examples yesterday. So I'll do one more review of the circle. Then we'll do a parabola review. And then we're starting with our friend the ellipse. So here we go. Let's find the center and the radius of x squared plus y squared minus 4x plus 8y equals 3. Now, I gave you, of course, a huge clue by saying find the center and the radius. But even if I hadn't done that, you should know that's the equation of a circle. How do we know that? X squared plus y squared, and the coefficients are the same. Right? J.A. Don't let him distract you. He's a bad influence. Now, our job is to find the center and the radius, which means the circle has to be put into standard form, which means we are going to complete the square. So here we go. Put your x's together. Put your y's together. And get ready to complete the square. Remember that if you are adding numbers to the left side of the equation, you also have to add them to the right side of the equation. Right? Okay, so here we go. Jade, what are you wearing?
My coat?
Okay, is that uniform?
No.
Okay, take it off, please. Thank you. Half of 4 is 2, squared is 4, so I'm going to add that to both sides. Half of 8 is 4, squared is 16. I'm going to add that to both sides. If any of the rest of you are wearing non-uniform, let's take it off. Someone stole my charger. I'm in a really bad mood. So if you know who it is, tell them to bring it back. My white charger thing that's back there. It's gone.
That's big.
It's the
Huge.
It's the
block about the oven.
yeah.
Someone took it.
Someone took it.
I assure you, it's like just like
Like a teacher.
How could it be misplaced? It was plugged in the wall.
What if a teacher?
There's a teacher during county.
Well, it was missing before counties.
What if they just
So it
borrowed
wasn't a
it?
teacher during counties.
It's not just like a little charger. It's like a lot.
That's a big thing to take.
I know. So x minus 2 squared, y plus 4 squared equals 23. So I completed the square on my x's and y's both. Make sure I added my numbers also to the other side. So now I can see my center is what? What? 2, negative 4. And my radius is? Square root of 23. X squared plus y squared is r squared. Just like it's been forever. Alright, so that's a circle. Alright, so I'm going to erase this now, because now we're going to do a parabola. So we are going to find all of the information, and I'll list it over there, for this equation. X equals, let's say, 1/3 y squared plus 2y minus 3. Now, by all the information, this is a parabola, right? How do you know it's a parabola? You got one squared term. So we need the vertex, the axis of symmetry, the focus, the directrix, the length of the latus rectum, and the endpoints of the latus rectum. Alright? So that's everything we know how to find for our parabola. Alright, so it is not in the shape we want it to be in, that equation, right? So you remember that the standard form that we want to be able to find all of this has a number and a parentheses and then a parentheses squared, right? That's what our equations look like. Something like, I'm making this one up, but 4 y minus 3 equals x minus 2 squared. That's the way we want it to look. So obviously, what do we have to do over here? If we want it to look like this, we have to complete the square, right? So we're going to do exactly what we just did with the circle, only we only have to do it once because we only have one square. But we do need to get rid of that.
In the fraction. Oh.
Yeah, we got to get rid of that. It's not even that it's a fraction. The reason I can't have it there is I'm going to complete the square. And when I complete the square, I can't have any number there, fraction or not. So I'm going to multiply through by 3. So now I've multiplied through by 3, right? Now I'm going to be completing the square over here, so I'm going to make room by getting rid of this number because I need to have a space here to complete the square, right? So I move that 9 to the other side. Okay, now, half of 6 is 3 squared is 9, so coincidentally I'm going to add a 9 to both sides. So I have 3x plus 18 equals y plus 3 squared.
Take out the 3.
Factor out of 3, and then my equation looks exactly the way I wanted it to. This is my standard form. Looks just exactly the way I hoped it would end up looking. All right, anybody have a question about getting from that original to the way I need it? Because now I'm going to use this to answer those questions. Graph is optional. I always do it because I can't do it without it. I need to visualize it. Where's my vertex?
Negative 6.
Watch it. Watch it. Negative 6, negative 3.
You know what I meant this for.
I know what you meant. Negative 6, negative 3. Now, that little mistake, which is easy to make, would be deadly. Right? Because this is the starting point. This is where you count everything. If you got that wrong, they're all wrong. So you want to really be careful. Take your time. Make sure you get your vertex in the right spot. The other thing you want to make sure you get right is which way does it open?
Right.
So you're going to look at two things. You're going to see a positive number, which automatically means upper right. And then you pay attention to which letter is squared. You got y squared. Y squared means right and left. X squared is your BFF. X squared is up and down. So this guy opens to the right. I'm a free-handed in. Nobody's grading the graph, didn't matter. Okay, so now I've got my parabola drawn. So now I know my axis of symmetry. What is my axis of symmetry? What is it? Y equals negative 3. Y equals negative 3. That means that every point on that line has a y coordinate of negative 3, including the focus, which is right there. That's the focus, always inside the parabola, on the axis of symmetry. Now I need to figure out what the coordinates of that point are. I know the y has to be -3, right? But I need to figure out how far it is from the vertex to the focus.
Isn't it 4P?
That's 4p. Actually, that's p. This is 4p. 4p is 3. This number is p. This is p. So p is 3/4 or 0.75. I don't know if you like, you're going to be adding and subtracting. I don't know if you like to do it with fractions or decimals. Doesn't make me any difference at all. Don't care. It's 3/4. So we're going to start at -6. And we're going to go forward 3/4. So where would we be if we started at -6 and went forward 3/4? -5 1/4?
Yes.
5.25 or 5 1/4 negative. Now, if you went forward 1/4, or excuse me, 3/4, if you went forward 3/4 for your focus, you're going to come backwards 3/4 for your directrix, right? So if I come, I'm at -6, I'm at my vertex. If I come backwards 3/4, where am I going to be? X is -6 and 3/4, -6.75, back 3/4. Now, this segment right here is my latus rectum.
It's 3.
I know that the length of it, and we use this notation, magnitude, length of the latus rectum is 3. Because the length of the latus rectum is always this number. Right? We talked about all this yesterday. Just to do a quick recap. Right? Now, if the length of the thing that is top to bottom is 3, then I could find these 2 points by starting in the middle and going up and down 1.5. So if I go up 1.5 from this point, I would be at -5.25, comma, -1.5. And then if I go down 1.5, I'm at -2.5, -4.5. And those are the endpoints of my latus rectum. Okay? Now, what's the definition of a circle? Gave it to you yesterday. Set of points. Set of points in a plane equidistant from a given point. That's it. Set of points in a plane equidistant from a given point. What's a parabola? Set of points in a plane equidistant from a given line and a given point. Those are called the focus and the directrix. Alright, now we're going to talk about the ellipse.
Oh no.
The ellipse is a set of points in a plane. The sum of whose distances from 2 fixed points is constant. Okay, I am going to go out and buy some squirt guns. And I'm going to shoot every single one of you so that you don't have to worry about it anymore and you can just focus on math right now. Okay? So, okay, but you know we're going to this has to be dealt with.
Yeah. Just write me on the board.
No, oh no.
Bit more.
More.
Okay.
All right, so we got 2 fixed points, and the ellipse is the set of points whose sum from those 2 is the same. So here's what that means. Everybody knows what an ellipse looks like. Here would be the two fixed points. Let me pick a point like right here. If I could measure that and let's say it was 3, and I could measure that and let's say it was 8, then the sum of the distances would be 11. Now that means if I picked another point, like maybe this one right here, and that distance was 5, then this distance would have to be 6. Because the sum of the distances, so let's say I picked one right here, and that distance was 2, then that distance would have to be 9. The sum of the distances from those 2 points is constant. Anybody want to take a wild guess what those 2 points are called? Those are the focal points. They're called the foci. That's plural for focuses. Focus and Latin deal. So we say foci. Those are the foci, the focal points. The ellipse has 2 of them. Obviously, the further apart the foci are from each other, what happens to the ellipse? As the foci get farther apart, it becomes longer, right? If the foci have converged to the center, we have a circle. The closer they are together, the more circular it is. All right, so let's talk about how we're going to find the foci and all that for an ellipse. All right, let's start with this equation right here. What is that?
Circle.
That's a circle with a center at the origin and a radius of 4, right? So if I were going to draw that circle, I would start here at the origin. I would count up 4 and out 4. Right, everyone? Connect those, and that would be my nice little circle. Now, what if I write that equation like this? Is that still the same equation? Is that still the same circle? Yeah. Okay. That still means that in the x direction, my radius number is 16, so I'm going to count out 4 in the x direction. But I'm also going to count out 4 in the y direction. That's what makes it a circle. Those numbers match. So what if I had this? Now it's not a circle, because this 16 is the x radius number. So that 16 still tells me to count sideways 4, right? But what does that guy tell me to do? Up and down just 2. So now when I connect those points, I don't get a circle. Of course I don't, because I went different distances. I get an ellipse. These 4 points, all 4 of them, contrary to what your book says, all 4 of these points are called vertices. Those are the vertices of the ellipse. So when you are asked to find the vertices, you're asked to find those outlying dots that you connect to make the shape. This right here is called the major axis. The major axis. As opposed to this, which is called the minor axis. So for this ellipse, the major axis has a length of 8, and the minor axis has a length of 4. Now, will the major axis always be this one? No, it depends totally on what? The numbers under here, right? The big number gives you the major axis, the little number gives you the minor axis. The foci are always located on the major axis. So whichever one is your major axis, that's where your foci are located. All right? Now, somebody usually says at this point, well, where do I put the foci of a circle? You don't. The foci have converged. They're at the center. Circles don't have both sides. The distance from the center to the focus of an ellipse is found using a Pythagorean idea. For this particular ellipse, this is what I'm graphing right here, the center to the focus would be the square root of 16 minus 4, or 2 root 3. So I would start at my center and go forward 2 root 3. So this is the point 2 root 3, comma 0. Backward 2 root 3, negative 2 root 3, comma 0. How did I find the distance from the center to the focus? I subtracted my denominators and took the square root. That's exactly right. I subtracted the denominators and took the square root. Every time, you're going to subtract the denominators and take the square root. Now, if you think you might ever make a mistake and add the denominators, you'll catch yourself. Because if you made the mistake and added your denominators, that would be the square root of 20, which is 4 point something. What would happen if you said the foci were 4 point something away from the center? They'd be outside the circle, or outside the ellipse. They've got to be inside. So in order to make sure they're inside, you're always going to subtract these numbers. All right, well, that's not too bad. Let's look at maybe a little more complicated equation. What if we had something like this? Wait a minute.
Does that mean your center are 1 and negative 2?
That means my center is no longer at the origin. My center is now at the point 1, negative 2. Actually, I'm going to have to draw this over here because I'm not going to have room there. All right, so my center is at the point 1, negative 2. Now, let's get our vertices. Let's get our vertices. Remember, this number serves as the x radius. So that 9 tells me I'm going to start here and do what?
So 3 that way.
1, 2, 3 this way, which is 4, negative 2.
And 3 the other.
Michael Bammer, what are you doing? No, you're not. Don't lie to me, okay? They're already stealing. He messed around with his phone. It's not been a good day. And it's Pi Day. I should be so happy today. Now I'm backing up 3 units, and I would be at negative 2, negative 2. Now, what does the 16 tell me to do? This one right here. What does this tell me to do? Start at your center and go up 1, 2, 3, 4, which puts me at 1, comma 2, and down 1, 2, 3, 4, which puts me at 1, comma negative 6. If you think graph paper will help you, get some graph paper. You are welcome to use it. Because we're just counting. I mean, that's all we're doing is counting. From the center. Now, major or minor? The thing I just drew right there. Is that my major or my minor? That's my minor axis. And my minor axis is 6 units long. How do I know that? Because I went backwards and forwards 3. My major axis this time is the vertical one. And it's 8 units long because I went up and down 4. Now your foci, your focal points, are somewhere on the major axis always. So I'm going to start right here at the center, and I'm going to go up, how far? square root of 7. Center to focus is the square root of 7. 16 minus 9. So, somebody asked me earlier, Mrs. Ford, how do you know if it's 9 minus 16 or 16 minus 9? How do you know?
It's the same thing.
Well, you don't want a negative, you're taking the square root, right? So it's big minus little. Now, where am I? What are the coordinates of this point? If I start at 1, negative 2, and go up the square root of 7.
You're at 1, negative 2 square root of 7.
1, negative 2 plus root 7.
Oh, my bad.
I'm adding root 7,
Right.
adding it. And then this one will be 1 comma
Negative 2.
negative 2 minus root 7. What are you doing? Okay, here's how this is going to work. Everybody here is on warning. Anybody in this class gets a phone out, inappropriate iPad use, anything like that, you're gone from this class until I have a meeting with your parents and you explain to your parents why you got kicked out of class. All right? So we are going to all stop, and we're going to use good sense, respectful behavior, no electronics. 0. Now, if you must take notes on your iPad, okay. But if you're not taking notes on your iPad, then you will get thrown out, and we'll have a meeting with your parents. Now, is there any question about that? Does everyone understand the directions? Okay. All of it's on video. Okay, so we all know we got the evidence. Okay,
No, it's an emergency.
all right. Okay, so from my center, I have counted up and down the square root of 7 because that was the distance from the center to the focus. All right, so one more that I'm going to give to you in this form. I think you probably know what's coming. Not all of your equations are going to be written in this form, but let's do one more. And I want you, I'll make a list of everything I want you to be able to find for one more problem. Here we go. X plus 2 squared over 25 plus y, oh, we'll make this one a little tricky, y squared over 16 equals 1. All right, here's your ellipse. Now, first of all, we know it's an ellipse because if it were a circle, these two numbers would be the same. They're not, so it's an ellipse. Here we go. I'm going to make a list and you're going to start filling it in. We need the center, we need the foci, we need the vertices, we need the major, and we need the minor axis. You're doing that on your own. I'll jump in here a little bit because I want to get it done before we run out of time, but. Everybody should have a center plotted, or at least, I don't know if you're graphing it or not, but you have a center filled in. What's your center? Negative 2 comma 0. We have not moved it around in the y direction. Your center is at negative 2 comma 0. Now, do you have your vertices? Hopefully. Your vertices are located where? Well, you got to move sideways and you got to move up and down from your center. So how far sideways did you move? 5. So you put vertices, hopefully, at 3 comma 0 and negative 7 comma 0. Everybody do that? That 25 is your x radius. That tells you to go back and forth 5. Now, what about the 16? What does that do for me? Up and down 4 from the center. So 1, 2, 3, 4. 1, 2, 3, 4. So my vertices, this is -2, 4, -2, -4. So for the vertices, if you're filling in the blanks over there, these are the vertices, you should have 4 of them listed. Anybody have a question about those 4 points? The major axis is how long? 10. You know it's 10, either by just counting, you can count, but when you built the thing, you counted back and forth 5, right? So that would make 10. And then your minor axis is 8, because you counted up and down 4. Your foci are on the major axis somewhere. Right? Somewhere on the major axis. Where are they? Well, I need to know how far it is from the center to the focus. How do I find the distance from the center to the focus? I subtract my denominators and take the square root. So 25 minus 16 is 9, and the square root of 9 is 3. So no radicals to worry about. Start right here.
So it's gonna be
Count forward 3, 1, 0.
then that's
Count backward 3, -5, 0. Those are your foci. Okay? Now, I don't see you tomorrow. On Thursday, we are going to have a quiz. I'm going to write it. You're going to have a quiz, and it's going to have a circle and a parabola on it. So you need to have mastered the circles and the parabolas. Then we will finish the ellipse.
It's forward. I don't think it ever got a chapter 7 packet.
Chapter 8.
Mr. Ford, I just saw your picture of Mr. Kowalski up there.
Yeah, he gave me he's gonna pass on his pass.
Circle and parabola, he said. Or did you say circle and
Can you turn that off and get it?
Can I get chapter?
It's the same one.
Oh, it's just